Tutorial number 3, question number 1. A small package is deposited by the conveyor belt on the 30-degree ramp at A with a velocity of 0.8 meter per second. We have the initial velocity, which is 0.8 meter per second. And what we need to find is the distance S on the level surface BC, which the packages comes to rest. Also, we have the coefficient of kinetic friction for the packages and supporting surface from A to C is 0.3. Because there is no, the package is sliding all the time, so there's no static friction at all. First thing first, we need to draw the free body diagram of these two periods from A to B. Here's our packages on the ramp of 30 degree. We have gravity, the support force, and also friction, which is 0.3 times support force. Here's our coordination. And also from B to C, here's our package, here's the gravity, here's the support force, and our new coordination. And again, the friction is 0.3 times normal force. Because this is two pieces of rectilinear motions from A to B. The forces on y direction is equal to 0. We will get the normal force is equal to 0.866 times the gravity. On x direction is equal to m times the acceleration on x direction. So mg sine 30 degrees minus 0.3 times the normal force is 0.866. Gravity is equal to ma x. So ax is equal to 2.36 meter per second square. Because it's rectilinear motion, so we can use our formula set, which is vb square equal to va square plus 2ax d. vb square is equal to 0.8 square plus 2 times 2.36 times 2. Because VB is positive, we can just see the direction from the image. So VB is 3.17 meter per second. Again, from B to C, we have all the force on y direction is equal to 0, so N is equal to gravity. The force on the x direction is equal to max, so 0.3 gravity is equal to max. So ax is equal to negative 2.96 meter per second square. Again, vc square is equal to vb square plus 2ax times s. So 0 is equal to 3.17 square minus 2.96 times the distance. So we have the distance is equal to 1.71 meter. Question number 2. The system is released from rest in the configuration show that time is equal to 0. Determine the time when the block of mass m1 contacts the lower stop of the body of the mass m2. First, we have the mass for these two blocks, which is 0.5 kilogram, and m2 is equal to 2 kilograms. And also the friction factors for block number 1, static, is to 0.1, for dynamic would be 0.08. Also, between the m2 to the slope, there are two friction factors. For static, there's 0.25. For dynamic, it would be 0.2. Also, d is equal to 0.4 meter. What we need to find is the time when m1 touch a contact m2, and also the distance of m2 traveling. We better draw free body diagram for this, for m1 and m2. This is m1. It has the gravity and also support from m2. We call it N1, and also the friction M2 applied on M1. We call it F. We set our coordination like this, and also for M2, we have support from the slope. We call this N2, and also the stress from M1. We call this N1, and also the gravity of itself. We call this M2 G, and also the friction M1 applied to M2. We call this F, and also the friction itself. We call this mu K2 N2. Because it is moving, so we do not need to think about this one, think about static friction factors at all. Okay, so we need to consider if it's M1 is really slip on M2, so we can assume if there's no slip, we can take free body diagram of the whole system, because if there's no slip, these two can be seen as a whole. 20 degrees. This one is N2, and here is M1 plus M2 G, and this is the friction. Here's our X coordination, here's our Y coordination. The force on the Y direction is equal to 0. So we have N2 is equal to M1 plus M2 G cosine theta. And also in X direction, it's equal to MAX. So we have U K2 M1 plus M2 G cosine theta minus M1 plus M2 G sine theta is equal to M1 plus M2, and the acceleration of the whole system 0.2 times 2.5 times 9.81 times cosine 20 minus 2.5 times 9.81 times sine 20 degrees, go to 2.5 acceleration. So we have the acceleration of the whole system is equal to negative 1.512 meter per second square. So as for block number 1 in x direction equal to max. So f minus m1 g sine theta is equal to m1 acceleration, which is equal to f is equal to 0.5 times negative 1.512 plus 0.5 9.81 sine 20 degrees, which is equal to 0.922 Newton. So for the max friction, M2 can apply to M1. We can use the static friction factor and M1 to calculate that, which is 0.1 times 0.5 times 9.81 times cosine 20 degrees equal to 0.461 Newton, which is smaller than 0.922 Newton. So we could say the relative slippage occurs because the maximum friction it can occur is smaller than 0.922. Then we need to recalculate the acceleration for block number 1 because the acceleration for the whole system cannot be used as A1 again. So for block 1, we have the acceleration in x direction, which is equal to 0.08 times 0.5 times 9.81 times cosine 20 degrees minus 0.5 times 9.81 sine 20 degrees, which is equal to 0.5 A1. A1 again is equal to 2.62 meter per second square. For M2, in x direction it's equal to max. Again, mu k2 m1 plus m2 cosine theta minus m2 g sine theta minus f is equal to m2 a2. So 0.2, 2.5, 9.81 cosine 20 degrees minus 2 times 9.81 times sine 20 degrees minus 0.08 times 0.5 times 9.81 times cosine 20 degrees is equal to 2a2. A2 is equal to negative 1.235 meter per second square. So the acceleration of mass 1 relative to 2 is equal to A1 minus A2 which is equal to negative 1.383 meter per second square. S1 relative to 2 is equal to S2 initial, which is equal to 0, and V1 relative to 2 initial, which is also equal to 0 because it will start at rest, and also 1 over 2 A1 relative to 2 times square. So we have 0.4 is equal to 1.383 times over 2 times t square. So we have t is equal to 0.761 second. For S2, equal to, again, S20 equal to 0 plus V2 when t equal to 0 plus 1 over 2 a2 t squared. We have 1 over 2, 1.235 times 0.761 square equal to 0.357 meter. Question number 3. A child A is swinging from a swing that is attached to the trolley that is free to move along a fixed rail. We can draw a diagram. Here's our trolley, here's B, and here's our rail. And here's the swing, and the child is at point A. We can define a cylindrical coordination at point A. So here's our UR, here's U theta. So here's theta. Here's L. So we can also define our another Cartesian coordination at B, which is fixed as long as we don't need to use it, but we need to know that here's two coordination existed. So what we have is L is equal to 2.5 meters, acceleration of A is equal to 3.7 meter per second square, theta is equal to 23 degree, and angular velocity is equal to 0.45 radian per second, and also angular acceleration is equal to negative 0.2 radian per second square. So we have our acceleration for cylindrical coordination. Because we assume the point B is not moving, so acceleration is actually to A relative to B is equal to r minus r theta squared. To write down our formula, and also there's no velocity and acceleration in UR direction, so we have equal to 0. Here is also equal to 0, equal to negative 2.5 times 0.45 square UR plus 2.5 times negative 0.2 U theta equal to negative 0.50625 UR minus 0.5 U theta meter per second square. And we need to express our acceleration at point B to our cylindrical coordination. So it is equal to 3.7 times cosine 23 degrees U theta plus 3.7 times sine 23 degrees UR is equal to 0.41 U theta plus 1.44 UR meter per second square. So acceleration of point A is equal to A relative to B plus B negative 5.0625 plus 1.44 UR plus negative 0.5 plus 3.41 U theta. So UA is equal to 0.93375 UR plus 2.91 U theta. So magnitude of it will be 0.93375 square plus 2.91 square is equal to 3.06 meter per second square. Question number 4. A 5 kilogram mass is placed on a rough inclined surface to slide subjected to a non-constant force. While t is measured in seconds, how much time will it take for the mass to reach a speed of 10 meters per second? First, we have mass is 5 kilograms. Theta is equal to 15 degrees. Static friction factor is equal to 0.45. Dynamic friction factor is equal to 0.4. P is equal to 5t in I direction. What we need to find is time t for when the velocity reach 10 meters per second. We need to draw a free body diagram. Here's our block, and it have gravity, the support force, and also P, and also friction. So apparently in y direction is equal to 0. So we have n is equal to mg cosine theta. There are two periods of this question. The first period, the P cannot overcome the friction as well as the gravity, so the block didn't move. So we use the static friction factor. After that, the block will move, and we'll use our dynamic friction factor. So in the first period, F in x direction is equal to 0. So we have 5t1 minus mg sine theta minus mu s mg cosine theta is equal to 0. So 5t minus 5 times 9.81 times sine 50 degrees minus 0.45 times 5 times 9.81 times cosine 50 degrees is equal to 0. T1 is equal to 6.8 seconds. So that is the time that it takes to make the block move. So after the block is moving, we have Fx is F. The sum of F is equal to max 5t minus mg sine theta. We need to change. We need to keep everything instead of the friction factor and the acceleration. So we notice that on the left side of the equation, we just have one variable, that is t. And so we can move dt to the left side of the equation and take the integral. So I have t1 to t minus 5 over m times t g sine theta plus mu k cosine theta. T is equal to dv 0 to v. So let's solve this integral. We have from t1 to t, and the right side is just v. Have our final equation, which is 5 over 2m t squared minus g sine theta plus mu k cosine theta t plus negative 5 over 2m t1 squared plus g sine theta plus mu k cosine theta t1 minus v is equal to 0. So we have t is equal to negative b, positive negative, b squared minus 4ac over 2a, and we have this part a, this part to be b, and this part to be c. After we solve this equation, we have t is equal to 10.8 seconds.